The slope of a line is the measure of its steepness. Now we can find the slope of a line given any 2 points on the line, as our first problem shows. Let's find the slope of the line between -3, -2, and 1, 3. Now the definition for slope is this. M is equal to y2 minus y1 over x2 minus x1. This is the algebraic definition for the slope, the difference of the y-coordinates over the difference of the x-coordinates. So I'll start by assigning this point coordinates x1, y1, and this point coordinates x2, y2. But it really doesn't make any difference whether I do it this way or some other way. So if I do it this way, though, I'll have y2 first, that'll be 3, subtract y1, which is -2, all that divided by x2, which is this point, that number right there, 1, minus x1, which is this number, -3. So I end up with 3 plus 2 divided by 1 plus 3. And so I end up with 3 and 2 is 5, 1 plus 3 is 4. 5/4 for the slope of that line. Now, we'll just leave the camera on this problem for a minute because it doesn't make any difference how I assign this x1, y1, x2, y2. I started by subtracting 3, started with the 3, subtracted -2, then I went to the 1 and subtracted -3. I could do it in the other direction also like this. -2 subtract 3. As long as the y-coordinates go on top and the x-coordinates go on the bottom. So I started here with this -2 and I subtracted 3. Now I start over here with -3 and I subtract 1. And sure enough, I get -2 plus -3, which is -5, divided by -3 plus -1, which is -4. And -5 divided by -4 is exactly the same as 5/4, because a negative divided by a negative is positive. So when finding the slope of the line between 2 points, it really doesn't make any difference in which direction you start subtracting as long as you stay subtracting in that direction. Y-coordinates on top, x-coordinates on the bottom. Here's another problem. Let's graph the line that has a slope of 3/2 and a y-intercept of -3. So my slope is 3/2, my y-intercept is -3. Well, the y-intercept tells me where this graph crosses the y-axis. So I'm going to put a point there at -3. That's where the graph crosses the y-axis. Now the slope m is 3/2, and slope is also defined geometrically as the rise in the graph divided by the run in the graph in going from any one point on the graph to another point on the graph. So this ratio of vertical change to horizontal change is another way to look at the slope of a line. We had an algebraic definition first. This is the geometric counterpart to that definition. So as long as I have a rise of 3 and a run of 2 going from any point on the graph, I'll get to another point on the graph. So a rise of 3 means I start at this point and go up 1, 2, 3, and then a run of 2 means I go 2 units horizontally. That must be another point on the graph. I can start at this point if I want and go up 3 and over 2. I'll be back on the graph. I could start at this point and go down 3 and back 2. As long as that ratio, -3 to -2, comes out positive 3/2, I'm okay. So now I'll draw a line between those points. And I end up with the line, the graph of the line, that has a y-intercept of -3 and a slope of 3/2. So there's a quick look at working some problems that involve the slope of a line.